Hello, you're welcome back. All right, so we are looking at more question in indices, logarithm, and sort. Okay, so here I have the very first question here. All right, so this is a question in indices or logarithm. Please pardon me. All right, so hopefully you can actually uh, the question is actually clear enough, but I can still write it down. All right. So the question right here, we're asked to evaluate, right, log of 4 in the base of 2, then plus the log of 16 in the base of half, minus the log of 32 uh, in the base of 4. Now, this question is a kind of tricky one in that the base, all right? Okay, the base are not really the same for me to apply multiplication or even division law. And of course, the base uh, are irrational. Like in this case, I have this the base is square root of 2 here. In this case, the base is actually 1 over 2. So simplifying this logarithm by applying multiplication law will not actually work, all right, or even division law will not work. But there's one simple way to actually solve this logarithm, all right? One simple way of solving this logarithm is to solve it individually, all right? You solve the logarithm individually. So I'll just show you how to do that. Okay, so for this, all right, so what I would do is this. Okay, I will change their basis to base 2. I will change their base to base 2. So I will change this, okay, this uh this log here to base 2. So that's gonna be log 4 in base 2. Then of course divided by the log of root 2 in base 2. Right, that's the only way I can actually go about it. I'll change this one to base 2 also. This is gonna be log 16 in base 2. Then of course uh that's gonna be log 1 all over 2 in base 2. I'll do the same to this. All right, so here we go. So this is gonna be log 32 in base 2, then of course divided by log 4 in base 2. So it is much easier now for me to apply power, right? Power law right here. Of course, you know very well that 4 is 2 raised to power 2. And of course, if I apply power law, the 2 will go at the back of the log. So that's going to be 2, or better still, let me write that down so that you understand what I'm actually looking at. This is going to be log 2 raised to the power 2, right? In base 2. Then, of course, divided by log. The square root of 2 is the same as 2 raised to the power of 1 all over 2 in base 2. All right, so this goes to this also, the same method. This 16 right here is 2 raised to the power 4 in the base of 2. Then divided by, of course, 1 all over 2 is a reciprocal. It's something as 2 raised to the power minus 1, still in the base of 2. All right, 32 right here is 32 32 is 2 raised to the power of 5, still in the base of 2, then divided by log 2 raised to the power of 2 in the base of 2. Okay, so I have to, this is the second question. Let me take it down. All right. Okay, so here we go. We can apply the power law. So the log goes at the back of the power goes at the back of the law. That's 2 log 2 in base 2. The same thing happens here. The power always go at the back of the log. Half log 2 in base 2. Then plus the same 4, right? Log 2 in base 2. Then all over minus 1, of course. That's minus log base 2 in base 2. Of course, minus 1 times log is still minus log base 2 in base 2. Of course, right here, 5 log 2 in base 2, then divided by 2 log 2 in base 2. Of course, log 2 in base 2 is 1, right? Log of the same base is 1. So I'm going to have 1 times 2. Okay, so this is going to be 1 times 2. That is going to be 2. Okay, 2 divided by half. When you divide 2 by half, you have 4. Okay, try that. 2 divided by half, we have 4. So let me just go straight. Of course, this minus here, this minus will affect this plus. So that I will have minus. Okay, because plus divided by minus is still minus. All right. So I have log 2 in base 2 is 1. That is 4 all over 1. Okay. Because log 2 in base 2 is 1. Log 2 in base 2 is 1. So this is 4 all over 1. So minus 4. Okay. So the same thing happens here. Log 2 in base 2 is 1. So here I'm having 5 all over 2. So 4 minus 4 is 0. So my answer now is minus 5 all over 2. Okay, so which of course in a mixed fraction is minus 2 whole number 1 all over 2. All right, so I hope that is well understood. So this is a method of change of base, but there's still another method, okay, that you would have actually applied, but that method will actually entails you solving this separately, okay? Then you now bring the answer. Maybe in another example, all right, or question, I'm going to show you that method. Okay, so this method is known as change of base formula. All right. Okay, here we go. So I'll still need to take this particular question down. Okay, so here we go. We have another uh, indices. 16 raised power of minus 1 over 2 times 4 raised power minus 1 over 2 times 27 raised power of 1 over 3. Okay, of course, to solve this, simply what I can do is, okay, solution. All right, so I'm gonna raise this to a power, this 2 raised power 4. Of course, bracket open minus 1 all over 2 times this is 2 raised to the power of 2 minus 1 all over 2. Then times 27 is 3 raised to the power of 3 times 1 all over 3. Of course, from what we have here, 4 all over 2 is 2. 2 times minus 1 will give me minus 1. So that's will give me minus 2, please pardon me. That's 2 raised power minus 2. Then multiply by 2 cancels 2. So here I'm going to have 2 raised to the power of minus 1. Then multiply by 3 raised to the power of 1. Of course, this is reciprocal. You know, this is the same as 1 all over 2 raised to the power of 2 times, you know, this is also the same as 1 all over 2 raised to the power of 1. Of course, times 1. Times 3. Okay, so if we did this 1 over 4 plus times 1 all over 2 times 3. So this is gonna give me 3 divided by 4 times 2. Okay, that is 8. So 3 all over 8 is the final answer. All right. Okay, so here we go. Next question. Okay, now this is an equation. So the question is if log Okay, so we have to solve the equation. The log of 64 in the base of x raised to the power 1 all over 2. The base is x raised to the power half is equal to 3. Okay, so I told you exactly how to solve equation and logarithm. We need to eliminate the log, right? So if we had log both sides, I would have cancelled the log. Since we don't have log both sides, I have to actually, right, use exponent. I have to take the exponent of the base. The base is x raised power 1 all over 2, okay? So what I'm going to do is that I'm going to take the exponent. So the exponent is, the base is 1 over 2, right, of both sides of the log. So x raised power 1 over 2, okay, of raised to the power of the log, which of course, 64, the base is 1 over 2. The same to happen here, x raised to the power of 1 over 2, all right, of course, raised to the power of 3. You know what happens? This base will definitely cancel this base, right? So we are left with 64 is equal to x raised to the power of 3 all over 2. Okay, so you know exactly what we are going to do at this point now. First of all, I'm looking for x, okay? I'm looking for x. So for me to actually find x, okay, I have to eliminate the 2 in the denominator, and I have to, of course, eliminate the 3 at the numerator. So what I'm going to do is this. I'm going to raise this both sides to the power of, okay, 2, then all over 3. Why did I do that? So that 2 can cancel 2, 3 will cancel 3. So, and whatever you do to this, to one side of the equation, you also do to this. You raise it to the power of, right? I'll see this other side, I'll do raise it to the power of the same 2 all over 3. That way, 2 cancels 2, then 3 cancels 3. So that x now is going to be equal to, okay? So, of course, let's see how we are going to do this to solve it. So, I want to find the cube root of 64, but if you can't find the cube root of 64, it's very difficult for you to actually know exactly how to find the cube root of 64. What you do is we are going to, let's use 4. If we use 4, 4 times 4 is 16. 16 times 4 is 64. That means 64 is, of course, the same as 4 raised to the power of 3. All right? Then, of course, times 2 all over 3. That way, 3 cancels 3. All right? All right, so 3 cancels 3. Okay, so I'm now left with 4 raised to the power of 2, which is equal to 16. As simple as that. All right, then here I have another question. So this time around, I'm to evaluate this. This also is gonna be is simple. Now, in this case, you discover that 81 all over 16 are all 12. The fraction is being raised to the power of 1 all over 4. So that means the power, all right, is actually the power of 1 all over 4 minus 1 over 4 is the power of 81. Of course, the power, also the power of 16. So this is the same as 81 raised to the power of 1 all over 4 divided by 16 raised to the power of minus 1 all over 4. Then multiply by 2 raised to the power of minus 1. Okay, so of course, you know how we are going to solve this. Okay, I think I can actually, okay, shift this. All right, so here we go. So 81, I will raise it to the power, right, of the base of 3. 81 is same as 3 raised to the power of 4. Okay, So times 1 all over 4. Then 16 is 2 raised to the power of 4. Then multiply by 1 all over 4. Then times 2 raised to the power of minus 1. 4 cancels 4. Then I have 3 raised to the power minus 1. 3 raised to the power minus 1. All right. Then, of course, at the denominator, 4 also cancel 4. I have 2 raised to the power minus 1 times 2 raised to the power of minus 1. So these are all reciprocal. You know what reciprocal is? For the minus 1 to disappear, right? I have to reverse the fraction. I have to reverse everything. So if I reverse this, this is going to be 2, of course, raised to the power of 1. That's 2 all over 3, okay? That's reciprocal. And of course, for this minus 1 to disappear, I have to also evaluate the reciprocal. This is going to be 1 all over 2. So everything, now, of course, 2 cancels 2. 2 divide itself, divide 2, 1. So I'm left with 1 all over 3. I'm left with 1 all over 3. All right, so that is the solution to that question right there. So I have another one. Okay, here we go. Okay, now as you can see, this particular question right here is having the same base. The base is 5. So I can actually apply addition law to simplify the indices. So this is going to be 5 raised to the power of 2 into x minus 1, then plus x plus 1. This is the addition law of indices, okay? In which you know very well that all you just need to do is to write one of the base, all right? Then you now add the powers. Is equal to, now the question is, what do we do to this the left hand side of the equation, since it's a decimal, all right? So what is going to happen is this, that decimal, we're going to convert it to fraction. You know how we do that now. You know very well that 0.04, if I convert it to fraction, right, that's going to be 4 over 100. You know that already, okay? 4 over 100, and of course 4 divide itself 1, divide 100, that's 25. So this is going to be at the right hand side, I'm going to have 1 all over 25. Okay, so let's actually do this. This is going to be 5 raised to the power of, I can as well open the brackets. This 2x, 2 times minus 1, that's minus 2. Then, of course, plus x plus 1 is equal to 1 all over 25 is 25 is 5 raised to the power 2. All right? So it's same as 1 all over 5 raised to the power of 2. Okay, so you know very well that collecting like terms, 2x plus x gives me 3x. Minus 2 plus 1 gives me minus 1. Okay, so now remember, solving this type of equation in indices, all right, I will have to make sure that I have the same base at both sides of the equation, so that I'll be able to cancel the base and solve for the and equate the powers. Okay, so of course, for me to do that, I have to find the reciprocal of this. So the reciprocal of this is 5, all right? If I reverse it, if I bring 5 up, it's going to be 5. Then the power becomes minus 5 raised to the power minus 2. That way now, the base can cancel out, right? 5, I have the same base both sides of the equation. It cancels out, so that I can now equate the powers. This 3x minus 1 is equal to minus 2. Of course, 3x is going to be equal to minus 2. Minus 1 goes over, becomes plus 1. Minus 2 plus 1, all right, is minus 1. Okay, so as a matter of fact, okay, um, my x is going to be equal to minus 1 all over 3. my x will be equal to minus 1 all over 3. Okay, so that is it. I would solve a lot of questions here. Okay, so it is your duty to go through these solutions, understand the principle behind the solution. All right. Okay, so that is it for this video. We are going to look at more in the next video. So see you in the next video. Thank you very much.